Live from Bangor Christian Schools, this is Geometry. Okay, part of the rules of videotaping, I will not use your real name. And that was Julio von Schnickelfritz in the background. Okay. Today we're going to be talking about slopes and slope of a line. One of the things that I'm seeing right now is that virtually no notebooks are out. So we need to fix that. We need to take our notebooks out.
I got it covered, Mr. T.
All right. Mr. T. Very good.
No, Mr. T. Mr.
Pity the fool. Okay. So we're going to talk about slopes today, and you've all seen this in Algebra 1. So for many of you who've had Algebra 2, this is going to be a bit of a, well, I've seen this, done this, but we're going to do it anyways. For those of you in Algebra 1, this is an excellent review for when you get into Algebra 2. Nobody takes this lightly, please, because we're going to be using these in the theorems and postulates down the road, okay? So I want to be able to figure out the slope of this line right here. And so in order to figure out the slope of the line, what I need are 2 points in order to do this. So I create a point here, and I create a point here. And so that leads me to the very first thing you need to know as a geometry student. You need 2 points, or 2 ordered pairs, to find the slope of a line. That's the first thing you need to know. So you need 2. Now what we do is we calculate what's called the rise and what's called the run. So what I'm going to do here, I'm going to create a dashed line, and I'm going to calculate the rise. So I start with this point here, and I go up until it matches the height of the point over here. So this part right here is called the rise. And so what I do is I just count. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. So the rise is 16 units. So what I do is I say, okay, the rise equals positive 16.
What lesson is this?
This is lesson 3.5. 3.5. Apologies, I didn't mention that. All right. Next thing I do is I calculate the run, and the run always goes left and right. Always goes left and right. So I start at this point right here, and I run over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 19, so 19 values to the right. So the run equals 19. So what I do is I now can calculate the slope. In algebra and in geometry, for whatever reason, I have no idea why, they chose the letter M. M is the letter that represents the slope. And so the slope is equal to the rise over the run. Rise divided by run. And so in this case, we get a slope of M equals 16/19. And that's, we can't really reduce that anymore. We could use a calculator, of course, get a decimal value, right? That's easy enough to do. But Bronson, I'm just going to leave that right there as 16/19. So we're going to use it that way.
What's his name?
Huh?
Julio.
Julio von Schnickels Nusenwatz. And my name is Mr. T. Okay. So, okay. Thumbs up, thumbs down. Thumbs down. So let's do another one.
No, that was good.
So we're going to calculate another slope here. Boom, boom. Okay. What part, by the way, does it matter which part you calculate first?
No.
It doesn't. You can calculate the rise first, you can calculate the run first. Does it matter which way you divide them?
Yes.
That does matter. The rise always has to be what part of the fraction?
The top.
The top, or the more mathematical term would be the numerator. Yes. Okay? So what I'm going to do is I'm going to calculate the run. So let's go ahead and do that. I'm going to calculate the run. And let's see here. Draw, that's done. I want red. And I go to the right. That's how many units. Okay, so how many units there did I just go to the right?
6.
6 units. That's exactly right. Here's how you can tell. Here's how you can tell. Right here, this is a -4, right? So I know that this is 4 units, and this is a 1, 2, 3. Oh, so guess who was right? How many units is this? 7 units. So I ran to the right 7 units. What is the rise going to be, though? Which direction do I have to go? Downward. So what I'm going to do here, Alicia, is I'm going to go down. I'm going to go down like this. And what I'm doing on purpose is I'm putting that in blue. The blue means negative, means a drop. So this means that the run was a +7. There we go. And the rise was a what? A negative what? -8. So it doesn't matter which one you calculate first. But it does matter which way you divide first. So, Joseph, what is the slope of this line, Joseph?
7. No.
You got this. Joe.
I'm thrown off by the Joseph. I'm sorry.
Okay, that's okay. Luckily, it has nothing to do with the calculation of the slope.
Joseph, come on. You got this one.
Use your brain.
I'm blinking. I'm sorry.
Rise over run.
Oh, sorry. -8 over 7.
-8, yes, over 7. There you go. Good. Okay. So what I'm doing here, Zoe.
Shanae.
You're Zoe. What I'm doing here is I'm going to put anything that's a positive number, I'm going to put that in red. Anything that's a negative number, I'm going to put it in blue. Okay? So far, so good?
So far, so good, Mr.
T. All right. In your notes, go ahead and calculate the slope of that line for me real quick. It'll just be a quick 30-second thing. See if you can calculate it for me. On your own. On your own. Try to calculate it. What'd you say?
So I don't want to write it down.
Bless you.
Yes.
Child, please be quiet.
Have you got it? Did you get it?
Me?
Yep.
Kinda.
Okay. I'm going to call you, I'm going to give you your YouTube name. I am going to call you Shaiqua. You are Shaiqua.
Hey yo, Keisha.
Okay.
Keisha, you know.
What did you get for a slope, Shaiqua? Yep. Listen up, please. Listen up, please. What'd you get?
Gonna go.
Did you?
The slope is horizontal, right?
Correct.
Okay. So it goes up 10
Okay.
over.
10 over 3?
Yep. Yes.
Okay. So she says 10 over 3. Is she correct?
Si, senor.
All right.
We're not in Spain.
So let's look at this.
We're not in Spain.
I'm going to start here. I'm going to calculate the rise. Listen up, please. Okay. I'm going to rise up 10 units. So we start here, rise up 10 units. So we're good there. And then I run over 3 units. So you're absolutely correct. The slope is 10/3.
Good job,
You got it. All right. One more, just for the sake of having another negative slope, because we need to be able to work with those too. Okay? Let's say I have the following point, following ordered pair. I'm going to connect those together. Okay? I'm going to give you a minute. Calculate the slope of that line for me. Okay, let's see. Okay. Let's see. I'm going to call you Home Skillet.
Yeah.
Okay, Home Skillet.
Is it -2, 1?
Negative 2 divided by 1?
Yeah. For the final answer.
Okay, so you reduced.
Yeah.
Okay, let's find out. So what I'm going to do next is let's calculate the rise. Change this into red real quick. Okay, so how much do we rise up from here to here? 12 units, right? So that's positive, which is why I put it in red. Okay, now let's change this to a blue color. How much do I run to the left?
6.
6 units. So since I run to the left 6 units, let me write this out. I rise up, that's a positive 12. And I run over, what would I call the run? Since I ran to the left.
Run left.
What number would I put since I went to the left? Negative 6. You're absolutely right, Home Skillet. Good question.
That's what we did a second ago. That's why I'm saying it was close.
Yeah, let's do that. Okay, let's see. Shaikwa, Home Skillet.
He's Josh.
I'm not going to call him Shanae.
Who's Keisha?
I'm going to call you Ken.
Don't call him Ziggy.
I'll think of something better later. Okay, Ken just asked a perfect question. He said, why not go the other way?
Can't graduate.
Okay, so what he means is this. If I start here, I run to the right 6 units, and that's a positive number, correct? Correct or incorrect? That's correct. I can run to the right 6 units. But then what do I have to do? Okay, front row, please.
That'd be you.
Yeah. What do I do after that? I drop down 12. Now what that does is that makes the run positive 6, makes the rise negative 12. Since the slope is rise over run, do I get a new number? I don't, do I? I still get the negative 12 over 6. So m equals negative 12 divided by 6, which actually I am very glad you asked that question, because what that means is that it doesn't matter which point you start from. That's what that means. I can start from the point above, right here, or I can start from the point below. So what'd you say?
So
Both of them are right. That's exactly right. So it is completely irrelevant where you start, so long as you take your steps correctly. Completely irrelevant, which is why that was a perfect question to ask. Okay? So I'll rename you Ken later.
What's Mandy's name?
Ignore
It's
that.
Mandy, obviously.
Okay, if what I'm going to do at the end of the lesson today is I'm going to let you write down what you want your YouTube name to be. If it's something I feel is appropriate and I'm willing to say out loud without cracking a smile, then I will use that as your YouTube name. Okay? You'll get to decide today. However, if I were you, I would keep homeskilling. And I'm very fond of the name Shaiqua. So those are pet names. Nobody in this classroom gets to use Frohickey. That's my special name.
That's my name.
You will not call me Frohickey, but I'm just saying that right now. I am Mr. T. Okay.
Mr. Partridge, hickeys are sexual and inappropriate.
Okay.
So very unnecessary.
You're gonna make it.
What if
You're gonna make it, okay.
Someone started Oh, okay, I got this.
Okay. No talking, please. Please. Hey. All right. Now, everything that we just did was graphical, and the graphical slope is the easiest one to find. Okay? You won't always be given a graphical value. Sometimes you'll be given just the ordered pairs like this, no graph. So what we need is we need a formula in order to calculate it. So this is what we do. What we do is we say that the slope m is equal to y2 minus y1 divided by x2 minus x1. Now, going back to his earlier question, when we had the graph up, it didn't matter which point we started with, right? Which means that it doesn't really matter if I have y2 first, or I can also have y1 minus y2 divided by x1 minus x2. In the same way that if you have a picture, it doesn't matter which point you start with. The same thing with this formula. It doesn't matter which y value you pick first, but you have to be consistent, okay? So if I was to calculate the slope of this line, what I would do right here is I would call this value x1, this value y1, x2 and y2, and then what I would do is I would say, okay, which one do I want to pick first? Which y value do I want to pick first here? So you choose one for me. What's a y value that we want to start with? We're given -3 or 8. You pick one. Which one do you want to start? 8. So 8 minus -3 divided by, now it matters. It matters now because he chose 8. So what does he have to choose as his x value? That's correct, -4. So -4 minus 2. And now all you have to do is that calculation. What's 8 minus -3? 11. Divided by -4 minus 2 is -6. And so there's the slope. We would say that the slope m is -11 sixths. Just like that. Okay? Let's do it the other way real quick. M equals, he chose 8, so now I'm going to choose -3 minus 8 divided by, what x value do I have to choose now to make this work? I chose -3 to start for the y value. So I have to choose the number 2. 2 minus -4. And now let's just do the calculation. What is -3 minus 8? -11. What is 2 minus -4? 6. They both turn out exactly the same.
I did that in a way easier way. I just combined the y2 and y1 and x2 and x1 in your head instead of doing all that. I'm just saying that's like a lot easier to say right now.
Even if you did that, it wouldn't be right. Because it'd be.
Well, in your head,
Yeah, it'd be fine.
in your head,
8, 9, 10, 11, then 4, 5, 6.
okay, in your head, you're actually using the same formula.
I don't really just like what he's doing right now.
But as your math teacher, let's just be honest here.
Kira, you decided to show up.
As your math teacher, no, I want to answer this question, so let me have quiet here. I understand what you're saying. You're able to look at the ordered pairs and you're able to say, oh, bam, there's the slope. And the human mind is an amazing thing, and our minds work rather quickly when we already see the pattern. So what you're telling me is that you already see the pattern. And that's good. I'm glad that you can already see the pattern. Here's the thing. As your math teacher, I have to see you write the problem formally on the page. So the answer to this question here is, I'm glad you know how to calculate the slope, and that will make sure if you can already do it, then you'll be right, but I need to see it written. And one of the reasons I need to see it written is because when you get into college, if you have to take another math class, you will need to know how to formally write the formula for a slope down on the page in order to do whatever your teacher in the future is going to have you to do. So it's not just the skill that I'm teaching you here is not just calculating the slope, it's actually getting it on the page to write it correctly on the page. Okay? So you're at an advantage. You already know how to look at the ordered pairs and say, well, there's the slope. That's obvious. You're at an advantage because that means that if you know how to look at the ordered pairs, then you've got it and you know what the answer is. Now you just have to develop the skill of, and maybe even the position of mind saying, I don't want to write it, but I'm going to anyways because that's what's being expected of me. Okay? So yes, every single one of you, I am expecting you to write the slope formula out. Okay? And that's just, it's part of the bigger picture. You may take a math class down the road, and he or she, whoever your professor is going to want to see you be able to do that. Okay? All right? Slopes are not, by the way, slopes are not always nice integers. 2.3, negative 4.5, comma, negative 3.45, comma, 9.98. All right? Now, this is the real world. You still have the ability to calculate the slope. But let me just ask you, can you calculate the slope easily in your mind without a calculator right now? Can you just look at the ordered pairs and tell me what they are? Maybe the answer is yes. Maybe you just want to say yes to contradict me in the video, which is probably more of an indication.
Yes.
Personally, I need a calculator, but I do want you to be able to write out the ordered pairs correctly. So I'm going to call this x1, y1, x2, y2, and so my slope is equal to, now, again, Shaikwa. I get to choose, yep, you're Shaikwa. You can start with this number, or you can start with this number. It's totally your choice. Which number do you want to start with? This one or this one?
That one.
This one, okay? So what you're going to do is you're going to write 9.98 minus negative 4.5 divided by, now it's not your choice anymore. Okay, so you chose this one, which means now you have to choose this one. Does that make sense? So negative 3.45 minus 2.3. Okay, I can clearly see that I have not begun class correctly because despite how many times I keep saying that there should be no talking, I see too many people having conversations. You're not doing right. You need to be part of the lesson whether you know it or not, okay? I am getting to a point where you guys keep talking and talking and talking. I'm just going to tell you right now, I'm getting a point where I'm just going to start giving detentions. And that makes my life miserable and that makes your life miserable. But I expect you, because you're old enough and you're in high school, you know how to behave correctly and you are capable of behaving correctly. So please, when it's lunchtime, talk to your heart's content. When you're in the hallway, talk to your heart's content. At least give me some impression that I'm not up here talking to myself. I can talk to myself at home. I've done that. It's not very fun. Okay? So please, at least give me at least some indication that you're here present in the room and that you are listening to what's being taught, because you will be held accountable for it, even if you feel like it's the easiest thing in the entire world. Okay? Okay, yes ma'am.
I've got a question. For like yesterday's test for the email, was that for yesterday's test or was that from the test for last week?
For yesterday's email.
Like,
Oh, that was for the quiz you had yesterday.
That was a quiz.
And
That was a quiz, yes. And
I have to retake it.
I've got the video ready for that. I just have to get it online.
Okay.
Okay? All right, let's calculate this real quick. What is 9.98 minus negative 4.5? If someone has a calculator, that would be very helpful. 14.48 divided by what is negative 3.45 minus 2.3? Minus what? 5.75. Oop, 0.75. There we go. All right, take those two numbers and divide them. 14.48 divided by 5.75. And what'd you get? You should get negative 2.51826,087 is what you should get for the slope. Okay?
We can just write like negative 2.51, right? Or negative.
I want to see your slope to the nearest hundredth.
So it's negative 2.52.
Negative 2.52. So always put your slope to the nearest hundredth if you need to write a decimal. Okay? All right. Okay, something that's really important to know is that if you have a slope which goes in this direction, just like that, all slopes that go in this direction are immediately negative. You know that the slopes are negative. Why does a slope of a line like this have to be negative? There's no choice about it. Why is this always the case? Which direction? The rise or the run? Since it doesn't matter which point you start with, if I started right here and then went down, I would have a negative rise, wouldn't I? But then I'd have a positive run. But if I rose up, I'd have a positive rise and I'd have a negative run. So either way you calculate it, this has to have a negative slope, because either the rise is going to be negative or the run's going to be negative. Okay? Thank you. Okay, that's something we're going to do after class. Okay? This right here always has to have a positive slope, because in this case, the rise and the run will either always be positive or both are negative. How could you get a rise and a run that are both negative? Yes, I could start here, couldn't I? And I could go down, and then from there, I could go over. So this right here would have a negative rise, and this right here would have a negative run. How does that turn out to be positive? Two negatives divided gives a positive. So that's why the slope is still positive right there. Okay? Maybe later. Okay? All slopes or all lines that are parallel have the same slope. All lines that are parallel have the same slope. And that really makes, it's common sense really. Whoa.
Scary.
Okay, so I connect these 2 points here. Okay? Now, really quick, since you're really good at calculating this in your head, what would be the slope of this line right here?
11 over 10.
Over 10. So, positive or negative 11 over 10?
Negative.
Negative. So, a negative 11 tenths. So, that means that if I put another point here, if I want to create a line that's parallel to that, I have to have a slope of negative 11 tenths. So, what I have to do is I have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I have to run over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put the point, and now you can see clearly here that the lines are parallel. They have exactly the same slope. So if you know the slope of one, then the other line that's parallel has to have the same slope also. Okay? Does that make sense?
Yeah.
All right. Now, when are two lines perpendicular? Okay. Home skillet, what is the slope of that line?
What's home skillet?
13 is the rise.
Yes.
The run is. Wait,
You're correct. 13 is the rise.
and 13 is the run?
Let's see. I don't think 13. You're close.
Yeah, 8, 12.
12. So the slope is 13 twelfths. Now, what does it mean to be perpendicular?
We intersect.
They have to intersect. That's the first thing. They have to intersect at 90 degrees. That's exactly right. Now, if I take the 13 and the 12, I'm going to switch them. So I'm going to create a point right here. I'm going to switch the 13 and the 12, and I'm going to make it negative. So what I'm going to do is I'm going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to run to the right 13 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12, close this, 13. So that's 9, and this is 5, so 5 and 8 is what I want. So right here. And then look at what I have. I have two lines here that are now perpendicular. And so what happens is I take the slope of the first one, 13 twelfths, I reciprocate it.
Those aren't perpendicular.
Okay.
Just go over one.
They are perpendicular.
They are. Are you
Yep, I am sure.
Can you make it wider?
Go
Maybe.
over one more.
I know that if I stretch it out, now here's the thing, we're talking about perspective here. This is the program's fault, but that's still perpendicular. That's still perpendicular. That's still perpendicular. I can try and make it look more perpendicular. Here's the reason why I know it's perpendicular. Because I know the slope of this line is 13 twelfths. And I know that a perpendicular slope will always be the negative reciprocal of that. So since this slope right here is negative 12 thirteenths, I know that this forms a perfect 90 degrees. Now, how the program plots that point out, it certainly doesn't look like it, does it? No matter how many ways I move this thing. But mathematically speaking, which is, by the way, you've heard me say this before and I'll say it again, you can't go by the picture. You have to go by what you're given. And you can only go by what you're given. So what this means is that two lines that are perpendicular are negative reciprocals of each other. So if I'm given a slope that's 1/2, first thing I do is I reciprocate that. So what's the reciprocal of 1/2?
2 over 1.
2 over 1. Now I just change the sign. So it becomes negative 2 over 1. So negative 2 over 1 is the perpendicular slope. So here's the original, and here's the perpendicular. Okay? If I'm given a slope of negative 5 over 4, the first thing I do is I take the reciprocal. So what's the reciprocal of negative 5 over 4? Negative 4/5, right? But then I change the sign. So since it's negative, it now becomes positive, right? So 4/5 is the perpendicular. And that's all it takes. That's it. That's all it takes to get a perpendicular slope. Once you have a perpendicular slope, you can graph it. Okay? Okay. All right. That's calculus. You don't want that.
Can we watch the video?
Can we take attendance?
We're
We pray.
still recording. Yeah, we're still recording. Right. Okay. You can watch the video tonight when I have it loaded online. Use slopes to determine. So the homework tonight is going to be the guided practice. All right. This has been Geometry at Bangor Christian Schools, and we're learning how to live together.
Bangor Christian Schools in Bangor, Michigan.
And what?
We're not in Maine.
Oh, we're not in Maine. We're in Michigan. So we're in Michigan. All right.
We have Michigan.
Reminding you that to have a good and godly day. For of what value is a good day if it's not also a godly day? God bless.